Get your math on.
Get your math on. Get your math on.
Get your math on. Get your math on. Get your math on. Man, I'm a baker and I just made some wonderful bean pies. I actually sell bean pies after I make them. I produce them and I make them, but I'm having a problem. I know when I made the bean pies that I made, I used about 3 tablespoons of butter. But now I got an order from a grocery store. They want 100 bean pies. And I don't know how to find out how much butter I'm going to need to produce 100 bean pies. I know I needed 3 to produce the bean pies that I have, but I don't know how much I will need for 100. Oh my goodness, what am I going to do? Does anybody know anyone that can help me, anything that can help me? Because I got to get this order and it's very important and it'll bring me a nice profit and income if I can fulfill this grocery store order. Boy, I need help. Well, my friend, you called the right person. You need the Math Doctor. Because in order to solve your problem with the bean pies, you need and you have to get your math on. Guess what time it is? It is time to get your math on again with the Math Doctor. I am here to help this baker that has the problem. He has 2 bean pies that he made. Delicious bean pie. Good Lord, they look good, don't they? He made 2 bean pies with 3 tablespoons of butter. And now he wants to know how much butter he's going to need to make 100 pies. He's perplexed. He's obfuscated. He is just totally frustrated because he doesn't know what to do. He called the right person. The Math Doctor is here to tell him and to tell you mathematics can help you solve this problem and many other problems. What he needs to know is this. He needs to know something called a proportion. A proportion is when you have 2 equal ratios. Well, if he used 3 tablespoons of butter to make 2 bean pies, he wants to know now how much butter to make 100. Well, we can make a proportion out of that. Let's look at it. So his proportion would look like this. He used 3 tablespoons of butter to make 2 bean pies. So that would be equivalent to the ratio of how many, which we'll call N, how many tablespoons does he need to make 100 bean pies? He can just make a proportion out of this and then solve the proportion. And we're going to stop right there because guess what? The Math Doctor is going to teach a lesson today on how to solve proportions. And we'll be able to solve this problem and any problem with proportions. As a matter of fact, let's go ahead and solve this one, the Math Doctor, and then we'll get into the lesson on more proportions. Whenever you have a proportion, I want you to do Wakanda for life. Bam! I want you to make an X. Because the way we solve proportions is we simply cross multiply. Make your Wakanda for life symbol, bam, an X, bam, an X. That's how we solve the proportion. So you multiply 3 times 100 and 2 times n. So 2 times n is 2n. That will be equal to, because there's a law in proportions that if you have two ratios and you do your Wakanda, multiply A times D will always equal B times C. That is a property of proportions, that when you, bam, do your Wakanda for life, the product of one will equal the product of the other all the time. So that means he can use now this proportion to help him find out how much butter he needs to make some more bean pies, 100 of them for his grocery store order. He called the right person at the Math Doctor. So 3 times 100 is 300. And we would just divide, because you want to get rid of the 2. You do the inverse operation. For my algebra students out there, what you do to one side, you do to the other. And that means he would need 150 tablespoons of butter to make 100 bean pies. Good Lord, good Lord. Now what we're going to do is watch a video by the Math Doctor on proportions. Let's get our math on. Let's get our proportions on. Roll the tape, please.
So let's go. Oh, look at cute little Mike. And his name is Big Mike. He must have a big appetite because you know he's not big, he's little and cute. All right. Big Mike is able to eat 210 pancakes in 12 minutes. In a pancake eating contest, Big Mike needs to eat 105 pancakes. How long will it take him to eat them? Well, when we have a problem like this, we can use a proportion because they've given us a rate. The rate is work done over time. What is the work? Eating pancakes in minutes. Work over time, all right? So the work is 210 pancakes. He's eating them. He can do that in 12 minutes. So we can make a ratio out of that, 210 out of 12, okay? And then that should equal another ratio using the same rate. So this is what it would look like. Notice 2 quantities have been given as a rate, as we said, the number of pancakes and the number of minutes to eat them. So we can make a proportion using the 2 quantities and making 2 equivalent ratios. It would look like this. Bounce with it, please. All right. So this tells us that 210 pancakes out of 12 minutes should be equivalent to 105 pancakes out of some number of minutes. That's what we're trying to find. So we put an X there. X marks the spot. All right. We don't know how many it takes him to eat 105. We're going to find out using the rate that it takes him to eat 210. Notice you must line up units. On the numerator, we have pancakes with pancakes. In the denominator, you have minutes with minutes. You cannot put minutes and then on the other fraction pancakes. They have to match up. Pancakes, pancakes, minutes, minutes. All right. Once again, what do? We cross multiply. X-Men, especially Storm. Well, that's just somebody I like out of the X-Men. X-Men or what? Wakanda for life. X. All right. So we multiply 210 by X. That gives me 210X. When we multiply 12 times 105, we get 1,260. Okay. Then we want to remove the 210 to get X by itself. So what do? Like we did the other problems, we divide by 210 both sides. That divides out to 1. And it would take Big Mike, cute little Big Mike, it would take him 6 minutes to eat 105 pancakes if it takes him 12 minutes to eat 210. So the answer 6 is only based on his rate that we were given that it took him to eat 210. You change the rate, we would change the answer of 6 to something else. All right? Next problem. Lupe Fiasco, I don't know if that's one of your favorite rappers, all right, but he is a conscious rapper. That's why I like him. Lupe put out 4,000 flyers advertising his new CD and sold 12,000 copies. How many copies will he sell if he puts out 7,500 flyers? So Lupe did an experiment. He put out 4,000 flyers and got 12,000 in sales. Now he's saying, well, what if I turn it up to 7,500 flyers? How many copies will I sell? This is good business mathematics right here, all right? So let's look at it. We can make a proportion out of this. If 4,000 flyers produce 12,000 copies, that's our first what? Ratio. That is a ratio. 4,000 produce 12,000 copies. We want to know 7,500 will produce how many copies? So we cross multiply, put up your hands, make an X, all right? When we cross multiply, we multiply 4,000 by X, we get 4,000X. We multiply 12,000 times 7,500, and we get an answer. You do it on your calculator or by hand, we get an answer of, that's a very big number, 90 million, I believe that is, 90 million. So now we want to get rid of the 4,000, okay? Yes, 90 million, just making sure. I know somebody out there was going to correct me. 90 million, all right. So we want to get rid of the 4,000. We divide both sides by what? 4,000, right? Because we want the X to be left by itself. So we do the inverse operation. If you divide that either on your calculator or long division, however you want to do it, we would get an answer of 22,500 copies. So this is helping Lupe with his business proportions because he has a ratio for one amount. Now he's trying to use that to find out for a higher amount, okay? Proportions are very powerful problem-solving tools. Okay, next. Now we want you to try. See if you can do these next problems by yourself, and then we'll come together and look at the answer. All right? Got a word problem for you all. We got a Will Smith problem. Watch out now. In a new I Am Legend movie, Will Smith needs to put on a 6-inch fire jacket for a stunt scene where he will be running through a building on fire at 98 degrees Fahrenheit. The director wants more suspense, and he requests the stunt coordinator turn up the temperature to 110 degrees. How thick must Will Smith's fire suit be for him to survive the new stunt? This is very, very important that we get our math correct because we don't want Will to lose his life or get burned. If you're a stunt coordinator, you have to know your mathematics and you got to know your physics and science, but mathematics, all right, in particular. So if you don't know your mathematics, you are going to have a hard time being a stunt coordinator or an engineer. Let's see what we can do to solve this problem. Oh, I forgot. I was supposed to give it to you. So try it for a few minutes and then we'll come together and see what you got, okay? Made the same proportion, right? If the suit, 6-inch suit was for 98 degrees, we want to know how many inches would it need to be for 110 degrees. So notice inches match with inches, degrees on the same level as degrees. They must match up like that when you do your proportion, all right? Now, what do? To solve a proportion, we cross multiply. I hope you did that. So we're going to multiply 6 times 110 and 98 times x, okay? When we do that, we get 98x equals 660. We divide both sides, as you know, by 98. 98 divided by 98 is 1. That knocks that out to 1, leaving us with 6.73 inches. So he only has to increase the thickness just a few more inches to handle a fire of 110 degrees. Very, very crucial that we know how to do these types of problems and get our math on because we don't want anyone to get burned or lose their life. Mathematics is so, so important to learn.
Thank you, Math Doctor. Thank you so much for that exegesis on proportions. We want you to know proportions are so valuable in so many different professions. When people design fashion, they have to make sure the sizes are in proportion with the person's height and weight and so forth. Pharmaceutical people, they have to make sure that the drug dosage is in proportion with the person's weight or their height or whatever. Engineers, they have to worry about proportioning the heights, proportioning the weights of the bridge, proportioning the temperature or whatever. All that is proportions. Very, very important concept in mathematics. Make sure you know how to use them, know how to do them, know how to make a word problem into them if you can use it to solve it. Proportions are very, very valuable. This has been episode 4 of Get Your Math On with the Math Doctor. I'm going to tell that baker what he needs to do in order to solve his problem so he can make 100 bean pies and give the Math Doctor one so I can eat it right now. But anyway, until next time, do the right thing, fight the power, and get your math on, because math is universal, math is everywhere, and math is in everything. See ya until next time. Next episode with the Math Doctor. Peace out. Take care.
Get your math on. Get your math on.
Get your math on. Get your math on. Get your math on.
Get your math on. Get your math on.
Get your math on. Get your math on. Get your math on.